Round two, here we go, 3.4.
Hey.
Trying to get ready for the test tomorrow. I don't really have time to go, I'm sorry. That got somebody's attention. So more problems just to work on, just kind of see what's going on. I see this problem here in number 1, and what I noticed right away is that I have a 4 in front of the E junk. I'm like, I don't really want that 4 there. So I'm going to divide both sides by 4. If I do that, I get e to the 2x equals 4. And whenever they say solve, you're really trying to look for x, right? You're trying to find the x.
Yeah.
The problem is the x is in the exponent. That's an issue. But we learned something yesterday that's kind of important about logarithms and exponentials. They're inverses of each other. So whenever you see an e thing, and you don't want an e thing, you want the stuff that's in the exponent, you log both sides. So I natural log e, and I natural log 4, because you can do the same thing to both sides. So I log both sides. And you know that natural log and e are inverses. So they undo each other, which means I now have e, nope, we just said we undid them, didn't we? What I meant is we have 2x equals the natural log of 4. Oh no, there's a 2 in front of the x, so let's divide by 2. And my answer is the natural log of 4, whatever that is, divided by 2. That is the exact answer. Now if you wanted to write down the decimal approximation, because you're that person, the approximation, not the exact answer, but the approximation is roughly 0.693. So if you were to type in your calculator, natural log of 4, hit enter, then divide by 2, you'd see 0.693. You may leave it as an exact answer as natural log of 4, all over 2 if you like. Actually, the way I would do it, so that's good, is maybe you don't remember this from just a little bit ago, but natural log of 4 is really natural log of 2 squared. And that's all over 2. But then that 2 really can be pulled out in front. So really I have 2 times the natural log of 2 all over 2. So the best answer, actually, if you're going to write it in final format, is the natural log of 2. This is the best answer, the most simple answer.
Do you have to get the most simple one?
Only in this class.
Not in depth. Yes.
The answer is yes, I guess. Yes. Letter B. In letter B, I see a similar kind of problem. There's an 8 in front first, or with, I should say, the E junk, so let's get rid of that. I'm going to move the 8 to the other side, so I get 5e to the x plus 2 equals 22. Then we divide both sides by the 5, so I get e to the x plus 2 equals 22 fifths. Yuck, I have an e, so I should natural log both sides. So I natural log both sides. And the natural log and the e, they cancel out. They're gone because they're inverses of each other. So now I have x plus 2 equals the natural log of, and I like to put a parentheses, it's not necessary, 22 fifths. I guess the way I would write that in my final answer would be negative 2 plus the natural log of 22 fifths. If you typed it into your calculator,
2.4.
no, I get negative 0.5184.
Oh wait, never mind.
I would take either of those. This is the approximation, and the top is the exact. You could have, I suppose, wrote the top as natural log of junk minus 2. That's fine. Questions on that one? In letter C, I see a 2 in front of the parentheses. So I divide both sides by 2. When I divide both sides by 2, I have 3 to the x minus 1 equals 5. Then I'm going to add 1 to both sides. So when I add 1 to both sides, I have 3 to the x equals 6. Oh my God, there's not an e there. What am I going to do? Log it anyways, who cares? Moral of the story is when you don't know what you're doing, log it. So I ln one side, I ln the other side. Why did I do that? I can use the log rule of powers. So if I'm using the log rule of powers, that means that the x can come down in front of the log. That means I have x times natural log of 3 equals the natural log of 6. And then kind of the cool thing is I can just divide both sides by the natural log of 3. So the answer is the natural log of 6 divided by the natural log of 3. If you're that approximation person, it's 1.631. So the logging is allowing us to attack the power that has a variable. That's the whole point of it, because we're using one of those rules from our logarithms. We can pull that exponent down. So that's a goal that we have, if there's an x in the exponent. This next problem is kind of a weird thing. The weird thing about it is there are e's involved. And so one of the things I want to remind you is that if you see something like x squared times x7, that's the same as x to the 9. So if you see two bases being multiplied, you add the exponents. You might not recall that, but that's a piece of information you should know. So if I see something like e to the 2 times e to the 7, then that's e to the 9. And if I see something like e to the x times e to the x, that's e to the 2x. Because you add the exponents, and x plus x is 2x. Now using that information, here's what I'm going to show you. I have factored the trinomial because e to the x times e to the x, when I would FOIL it back out, would give me e to the 2x. Negative 5 times positive 4 is the negative 20 I see for my constant. And if I look at the inners, negative 5x, and the outers, positive 4, I mean e to the x, excuse me, then I would have a total of negative 1 e to the x. So this is the factorization of that trinomial, just like you would factor anything else. What this is saying, just like with any normal factoring, is that one of these parentheses has to produce a 0 out. It's called the zero product property. So I really have two problems going on here. I have the problem that says e to the x minus 5 could be my 0. And I also have the problem that says e to the x plus 4 could be a 0. And I need to check them both. So if I do the red one, that is saying that e to the x has to be a 5, because I moved the 5 over to the right-hand side. And then to undo my e, I have to ln, log it. So I log both sides, ln, which means that my x is the natural log of 5. So this is one solution, natural log of 5. If I look at the other part, and I move the number stuff to the other side, I get e to the x equals negative 4. And then I have to undo that e thing again, just like I did earlier. So I ln it on both sides. And I get x equals the ln of the negative 4. Which means,
You can't have it.
can't do it. There's no solution to this. We talked about that the first day. So there's no solution. So my only answer that I get out of this whole process was the natural log of 5. So don't forget some of the other things that we've talked about in this class, like the fact that you can't log 0 or negative numbers. Not so bad. Okay, the next one, in number 2, it says solve the following logs. Doesn't really tell us how to do it. All right, so we can use any method possible. And if I can use any method possible, I guess I'm going to divide by 2 on both sides.